Hello there everyone. So today this is a solution video to the complex number question, or the assignment that I put up on the website. So this is the second assignment overall, and so I'm going to go through it. So the first question on it was as follows. So you were asked minus 4 plus 3i is one root of the equation az squared plus bz plus c. Write the other root. So we know from the complex root, or complex conjugate, that if minus 4 plus 3i is a root, well then the other root is going to be minus 4 minus 3i. So again, it's fairly straightforward. Now, and that's all, that was literally just knowing that. You just have to know that there was nothing else to do with that part there, okay? Now, so it's 5 marks for that. So use the marvellous to express 1 plus I to the power of 8 in its simplest form. So we had to write 1 plus I to the power of 8. So this is fairly straightforward to Marvelous Theorem, but again, it's about confident knowing how to approach the Marvelous Theorem. So what you do is you start off and you find out what or is. So or is going to be equal to the square root of 1 squared, because it's 1 here, and I is multiplied by 1, so it's just going to be plus 1 squared. So that gives us the square root of 2 as or. Now, what I always do with these questions is as follows. Sorry, just go back up here. Now, what I always do with these is, I always draw a little diagram to give me an idea of where it's going to be. So if we say 1 and 1, okay, so we know that this is root 2, and I want to figure out what this angle here is. So the opposite over the adjacent is 1 over 1. So I can say that tan theta is equal to 1. So if I go and I check my tables book, so if you go to your tables book and you find out what tan theta is equal to 1. Now it's fairly obvious from this, you can see that it's 45 degrees, okay? But just to confirm that, so what you have here is tan theta is 1, it's 45 degrees, and that's page 13 of your tables. So theta is equal to 45 degrees, but we write it in radians, so that's pi over 4. So now I can go and I can write the following. I can say that 1 plus I is equal to root 2 times cos pi over 4 plus I sine pi over 4. And now for the Marvelous Theorem, you have to do the following. Okay, so that's just going to be root 2 to the power of 8 cos, you multiply this by 8, so it's 8 pi over 4 plus I sine 8 pi over 4. So what I've done there is the Marvelous Theorem. So when it was to the power of 8, you multiply this, you put this to the power of, so this one here goes to the power of 8, and you multiply this by 8. Alright? Now, that leaves us as follows. So you can see then, so you can type this into your calculator, or you can work it out, whichever you'd like to do yourself. So if you do bracket root 2 to the power of 8, it gets me 16. So that's equal to 16. Now, cos 8 pi divided by 4 is cos 2 pi. So make sure your calculator now is in radian mode. That's a key trick. So 1 plus, and then it's going to have sine 2 pi. Sine 2 pi, and that's equal to 0 pi. So that's in effect equal to 16. So in its simplest terms, 1 plus I to the power of 8 is equal to 16. Now the last part of this question says 1 plus I is a root of the equation z squared plus minus 2 plus I times z plus 3 minus I. Find its other root in the form n plus ni. Okay, so I'm just going to clear this and we'll do this. Now, so we know, okay, that z squared minus z times sum of the roots plus the product of the roots. Now, it says here 1 plus I is a root of that equation. Okay, So find sort of written in the form n plus ni, where mn. So what I can see here is as follows. So I've got plus z times that there. So therefore, if you take this part here, now the trick to this is a lot of people will say, so you're going to have 1 plus I plus a plus bi, and they'll do equal to minus 2 plus I. So this is your complex number you're trying to find, a plus bi, or n plus ni. And what a lot of people will do is they'll do this here. But the trick to remember is, see the minus sign here and the plus? That's the little catch. So what you should do to allow for that is as follows. You should just do that's equal to 2 minus I. So now I can say is 1 plus a is equal to 2, and I plus bi is equal to minus I. So here I can say that a is equal to 1, and now then b is going to be minus 2, because I minus 2i. So that would then give me, following that, you're going, now the way to test this is as follows. You're saying that your complex root, the other root, is going to be 1 minus 2i. So to test if this is right, I'm going to multiply it out, and it should equal, if I'm right, 3, because that's the product. So if I get 1 minus 2i, and I multiply it by 1 plus I, what do I get? So I get 1 plus I. So let's multiply this out. That's equal to 1 minus 2i plus I minus 2i squared. Okay, now, so that's going to get me, that changes to a 3, minus 2, minus 1 is plus 2, 2 plus 1 is 3, minus I. If I go back up here, product of the roots is 3 minus I. I multiply that out and I have 3 minus I. So therefore I can say that n plus ni is 1 minus 2i. And that's all there is to that question there. Alright, so I hope that kind of made sense. We're going to go on now and we're going to look at the next question. Okay, just clear this bit here. And we look at the next question. And just put a line in here. Okay, so our next question was this question here, question 2. And we had right. So let's have a look at this here. We'll just make that a little smaller. So it says let z1 equal to 1 minus 2i. The complex number z1 is a root of the equation 2z cubed minus 7z squared plus 16z minus 15. Find the other two roots of the equation. Okay, so we know what our complex roots here, that if 1 minus 2i is a root, then 1 plus 2i is going to be a root. If I then put them into the formula that we just did, z squared minus z times sum of the roots plus the product of the roots, which is how to form a quadratic equation, that will give me a quadratic equation in terms of z. I can then divide that in here to get the real root. So that's the procedure we do with that. And that's, once you know that, that's the main thing. So what I do is I start off and I do, right, so I've got, so this is part A. So 1 minus 2i and 1 plus 2i are two of the roots. So that's going to be z squared minus z times sum of the roots. So let's add these together, sum of the roots. 1 plus 1 is 2, minus 2i plus 2i, so it's going to be 2. Plus the product of the roots. So that's going to be 1 minus 2i times 1 plus 2i. Okay, so that's z squared minus 2z plus 1 minus 4i squared, which is 5, plus 5. So that's 1 times 1 is 1, minus 2i, plus 2i, minus 2i squared. Plus 2i and minus 2i cancel. The minus 2i squared becomes plus 4. 1 plus 4 is 5. So that's what I have there. Now, the next step of this here is as follows. So I need to take z squared minus 2z plus 5 and divide it into this here. Okay? So we're going to have z squared minus 2z plus 5. And that's going to divide into z cubed minus 7z squared it's plus 16z minus 5 minus 15 plus 16z minus 15. Okay, so this is a long division, and this is how they can ask this. So you have to remember with complex numbers, there's a good chance you're going to get asked a lot of the algebra stuff. And so, as you know from the course I've been doing, we did algebra first to kind of cover this, to take us into complex numbers. And you'll see this quite a bit now. So we're going to start seeing this with the different strategies that happen, the different type topics that we do. There's a lot of the algebra stuff that feed into it. Okay? So here, we start off with z squared, you multiply it by z. So that gets me z cubed minus 2z squared plus 5z. Then subtract that. Now again, just be careful, this is very, very important just to put your signs. And it's such a common mistake for people to make. They slip up with the signs because they think it's something you learned back in first year that it doesn't really apply, and yet it's a critical part of maths. Okay, so z cubed minus z cubed cancels. So minus 7z squared, now that's a minus, the minus changes to a plus. So minus 7z squared plus 2z squared is minus 5z squared. 16z minus 5z is 11z minus 15. Okay, now what you're then going to do is, that's going to get you, now I just want to make sure it's that right. So I have 1 plus 1 minus 2z, 5z squared. I think I take that down because that's going to multiply to 5. So let me see. Just trying to think here. Plus 2, right? Yeah, 2. So sometimes just something like this might come up. You just take your time with it, okay? And if we do that one there, it's going to be 1 squared minus 2 is minus 2. It's minus 4 squared. Yeah, it's 5. Yeah. Minus 2z. So I've made a little mistake here somewhere along the line. So it's 2z cubed minus 7z squared. So there's my problem there. Okay, so sometimes, and it's just something very simple, okay? So I was looking at that, and there's no harm for you to see that sometimes you can make a mistake. And so if this happens in an exam, now that was not by, that was by accident, not by design, but I'm glad that happened, because what it does is, it allows me, so I'm looking at this and I'm looking ahead and I'm realising, well, this isn't going to balance with this here, it's not going to work. So you have to find your mistake. And this happens in an exam because you're under pressure. So the trick to it is to find out. So what I've done is, look, a really silly mistake, but can easily happen, because look, I took the equation there wrong, it's 2. And I just wrote z. But that's very, very easy to rectify. So that's actually just 2. And then what I do is, so you just rub this out and you start again. So I know then that's going to be 2z. So now 2z times z squared is 2z cubed minus 4z squared plus 10z. So that cancels. So now what I'm going to get here is minus 7z squared plus 4z squared is 3z squared. And then it's going to be plus 6z minus 15. And now I'm going to multiply that by 3, which gets me 3z squared minus 6z plus 15. Okay, just make sure you've got your sign right. So that's actually minus 3z squared. So I'm going to multiply this by minus 3. So what I've done there is, so look, that cancels. Minus 7z squared plus 4z squared is minus 3z squared. 16z minus 10z is 6z. Now you bring down your minus 15. You multiply that by minus 3, gets you minus 3z squared plus 6z minus 15. And that lets you with 0. which means 2z minus 3 is a root. C let equal to 0, and that's just the root. That's all you're looking for. Okay, so it was no harm for you to see there with a question of that what happens when you might have taken something down wrong. But what I hope you've got from that is that you realise if you know your method is right, that's the key thing. So I knew my method was right, and I had complete confidence in that. And what a lot of people do is they make a silly mistake like that, and the first thing to do is they doubt themselves. So it's important not to doubt yourself and trust in your own mathematical ability. So again, I have the confidence from years of experience, and that's different for me. But what I hope from you guys will see is that you can have that confidence as well, and to actually look for the simple mistakes first rather than doubting yourself. And then if that's not working, then you might say, okay, maybe I've done this wrong. But the most important thing is first to trust yourself completely. Give yourself that trust. You owe that to yourself. You know, you've put the work in, and that's what comes down. And more often than not, it is just a simple mistake. Okay, now, B, it says, let W equal to Z1 times Z bar 1, where Z bar 1 is a conjugate. Plot Z1, Z bar on the diagram and label each point. Okay, so I'm just going to draw this diagram out here. So we have this as follows. Okay, and we've got, so it's 1, 2, 3, 4. Minus 1, minus 2, minus 3. Okay, we're asked to label the point. Now, so plot Z1, so Z1 is 1 minus 2i. So 1 minus 2i is there. Okay, and Z bar 1 is going to be 1 plus 2i. Now, you're asked to find the measure of, now, and label each point. So always make sure that's just giving away marks if you don't do that. So that's going to be Z1, Z bar 1. Right, and label each point. Now, it says find the measure of the acute angle. So the acute angle formed by joining Z1 to W to Z1. Okay, now, so we know that W is equal to Z1 times Z bar 1. So we have to work that out. Okay, so W is equal to Z1, which is, let me see, 1 minus 2i. Times 1 plus 2i. Okay, so that's equal to 1 minus 4i squared, so it's going to be minus 4i squared. So that's equal to 5. 5 plus 0i, which is going to be this point here. Okay, just going to extend this. And again, how did I know that? Because it tells me here that W is Z1 times Z bar 1. Where Z bar 1 is the conjugate. Okay? And I have to plot W. So plot W. That's not me W there. Okay. Now, you're asked to find the acute angle. Okay, so the acute angle. So let's draw this acute angle. So the acute angle is as follows. This is just a little bit of trigonometry. So this is how I work with this. Okay? Now, if I take this bit here and draw a line down here, okay, and then say I took that bit there. So again, this is something that they do, okay, so you can see that bit there. They try to bring in, say, the likes of trigonometry or another part of maths into paper 1. So what I'm going to do is I'm going to work out this angle here, right, and then I'm going to double it. Now if you look here, this angle here goes from, so the opposite side there is 2. And the adjacent side is 1 to 5, which is 4. So opposite over adjacent is a half. So I can say that tan theta is equal to a half. Now, if you look that up there, there's nothing there to give you that. So you have to go to your calculator. So you go, now, it's no harm to put this one into degrees to do this question here. Sometimes you need to use degrees. So what you're going to do is tan inverse 1 over 2. And that gets you, so theta is equal to 26.565. So you're going to multiply that by 2. And the reason you're multiplying it by 2 because the acute angle you're looking to get is as follows. Is this angle here. It's the whole lot, the red part. Whereas I've got the green part. So if you look at as follows, the green part, we were able to use the opposite over adjacent because that created a 90-degree triangle. That just doubles down to here. So to get the red angle, which is what we're looking for, that red angle there, we double that there. So you multiply it by 2, and it gets me 53.13. So it says to the nearest degree, so that's equal to 53 degrees. So again, tricky enough question. It was a little bit trappy. You know, just the way it was worded. It looked a lot easier than it was. It wasn't that difficult. So the important part was just, so look, that's Z1, that's Z bar 1, and W, you get to multiply that out. And again, just multiplying this, again, if you know the difference, 2 squares, you got 1 minus 2i, 1 plus 2i, so it's 1 squared plus minus 2 squared. That's going to be minus 4i squared. That gets me 5. So now that's 5 plus 0i. So that's why that's there. You connect them up, and then you realise you can split that in 2 to make the 90-degree triangle. Remember, a lot of trigonometry, you always come back to the 90-degree triangles. That's just something to remember. So that was that question there. All right. And again, like I said, like, and on this assignment you're not sure of, send me off an email and I'll explain anything you'd like. Now we're going to look at the third question. And again, just need to clear this. It's just some other work I was doing. Okay. And we'll do this one here. Okay. Leave that broken line. So this is this last question here. And yeah. Okay. So again, a fairly straightforward question. The hard part here might be the demover part. So it says 4 all over 1 plus root 3i is a complex number. So to verify that can be written as 1 minus root 3i, we multiply above and below the line by the complex conjugate. Okay, and again, that's because you're multiplying the bottom of the line, okay, or denominator, by its conjugate, which means you're using the difference of 2 squares formula. So that will mean you'll end up with a rational number. Okay, so we'll start here like this. I'm going to do, so you've got 4 over 1 plus root 3i times 1 minus root 3i. And like I said, look, because the bottom you're going to have 1 squared, and it's going to be root 3 squared, which is 3, so it's going to be 4 on the bottom. Okay, and at the top then you're going to have 4 minus 4 root 3i. At the bottom, when you multiply them out, you get 4. So that's equal to 1 minus root 3i. That's all there is to that. And once you, even if you write that there, and technically, you don't really need to actually do the multiplying. If you just write that like that, once you show you know how to do it, you can get your max. Okay, it says then, plot that on an arc diagram and write in polar form. Okay, so we've got 1 minus root 3i. So to plot that on a diagram, right. So 1 minus root 3i. So again, this is no harm because it shows you what quadrant it is. Sometimes it won't be giving it this as straightforward. Okay. And again, just fill in your arc diagram. So I've got 1, 2, 3, 4. Minus 1, minus 2, minus 3. Nice and big. Okay, so if I get root 3, right? So square root of 3 is equal to 1.73. So it's around 1 3/4, okay? So you're looking at 1 minus, so minus 1 3/4, so it's going to be in and around here. So roughly, that's that there. Okay, now, so that's going to be Z. And always label it. There. You have to write in polar form. So to write in polar form, we need to, first of all, measure that distance there. So we get R. So we know that R is equal to the square root of 1 squared plus minus root 3 squared. So that's equal to 2. 1 plus 3, so it's 2. Now, the angle we're going to get, right? So what I'm going to do is, the angle, now some people, this is what they do. They get this angle and they measure it the whole way around, right? My style is, my strategy is as follows. I get this angle, and because it's underneath, just change the sign of it. Okay? So to get that as follows, and it gives you the same answer. Okay, if I just draw that up like that, draw it like that, I've created my 90-degree triangle. So this side here is 1, that's root 3. So opposite over adjacent is root 3. So I'm going to say, I'm going to call that alpha. So tan alpha is going to be equal to root 3. So alpha, I check my tables book here, and it's equal to pi over 3. So therefore, I'm going to call theta, in this situation, because of the location or the quadrant it's in, is going to be minus pi over 3. And so now I can do the following. So that's minus pi over 3, and r is equal to 2. Well, then I can say that, so just let me see here, it's 1 minus root 3i. So I can say that 1 minus root 3i is equal to 2 times cos minus pi over 3 plus I sine minus pi over 3. Okay? Now, the next part of this question is as follows. So you're asked, use the Marvelous Theorem to show that z to the power of 10 is equal to that there. So I have to work out what this is to the power of 10. Okay? So if I use the Marvelous Theorem, so I can say as follows. So 1 minus root 3, and again this comes down to your algebra and how you rewrite something. 1 minus root 3i to the power of 10. It's going to be equal to 2 to the power of 10. Okay? So it's cos minus 10 pi over 3. That's just the Marvelous Theorem. Plus I sine minus 10 pi over 3. Now, with this assignment, don't forget to change it back to radian mode, just from the last question. So it's shift, setup, and then you do radian. Okay. So leave 2 to the power of 10. Let's extend the board a bit. Okay. So we leave 2 to the power of 10. And I get 2 to the power of 10. Now, cos minus 10 pi over 3. That's equal to minus a half. Now, sine minus 10 pi over 3. And that's equal to root 3 over 2 pi. Okay. First of all, I'm going to use one of the 2's here. So I can say 2 to the power of 9 minus 1 plus root 3i. And then all I do is change the sign. Minus 2 to the power of 9, 1 minus root 3i. Okay. And minus 2 to the power of 9, 1 minus root 3i. So you've got 1 minus root 3i. And that's that. So again, that was the assignment, guys. I hope you found it alright. I hope that's brought a bit of clarity to it. And you see what complex number that it's the same kind of style. And as I said, the more you practice these questions, the more you just get used to this style and the system involved. Okay, so any questions on that, you can just email me at the usual email address. So if you're looking stuck, or if you have any questions or would like any explanations on that, it's just robk.mathsplanations@gmail.com. Okay, and honestly, guys, any questions, just let me know. So, that's it. So, thanks very much, and I'll talk to you. See you soon. Cheers.